Hello, fifth graders. This is Mrs. Kelzer, and I've got a video on inequalities for you. You have a sheet with two problems. This is the one about Keith. If you are comfortable, you should try it on your own first. If you're not so sure, let's do this one together, and you can try the next one on your own. Once you're done trying the problem, check back and see if you've done it correctly. Alrighty, so here we go. Keith has $500 in his savings account at the beginning of the summer. He wants to have at least $200 in his account at the end of the summer. He withdraws $25 every week for food, clothes, movie tickets, and other fun things. And your job is to now write an inequality that represents Keith's situation. So we need to identify the important information. Keith has $500 in his savings account at the beginning of the summer. He wants to have at least $200 in his account at the end of the summer. He withdraws, that means removes or takes out, $25 every week. Next, we need to identify and define our variable. So what is it that we don't know in this situation? Well, yeah, he's going to withdraw $25 every week, but for how many weeks? I don't know. If you don't know, you need to use a variable. And you pick your variable or define your variable, and maybe we'll say W is going to equal the number of weeks. Okay, and so then you go ahead and write your algebraic expression that's going to represent the amount of money that he will be spending this summer. So he will be doing $25 every week. So 25 times W, or 25W. That's what he's going to spend. Since he's spending it, he'll be taking it out of his account. His account started with $500, and he's taking this amount, 25W, or 25 times however many weeks, out of his account. So this is what's going to be left in his account. He starts with $500 and he removes this amount of money right here. So this is what he's got left in his account. So now we go back and we go, and it needs to be at least $200. So it could be 200, it could be 201, it could be 250. That would all be fine as long as it's 200 or more. So the amount of money in his account, again, that's this part right here, has to be greater than or equal to $200, because he wants to have at least $200 left in that account. So it has to be 200 or more. You could write it the other direction. 200 would be less than or equal to 500 minus 25W. Alrighty, and on to the next problem. Okay, in this one we have the yellow cab taxi company, and if you've not done this problem, I want you to try it on your own first and then check back with me and make sure you did it correctly, or if you get stuck, you can check back. Alright, you're back. Did you circle your important information or identify your important information? It is a flat rate of $1.75. That's very much like the towing company problem that you might recall from last week, where it was a certain amount just to have them come out. In this case, it's $1.75 if they're going to take you anywhere. In addition, it's 65 cents per mile. Okay? And that's the information for what it'll cost you when you call the cab. Here's another thing to note. Katie has no more than $10. Let's imagine she has $10 in her pocket, which means her ride needs to cost $10 or less. $10 is fine, $9 is fine, $8 is fine, $11 is a problem because she doesn't have that much. So let's write our algebraic expression for the cost of her ride. We know it's automatically $1.75 plus, oh, wait a minute. We are missing some information. It's 65 cents per mile, and I don't know how many miles she's going. If I don't know that will have to be my variable. So we'll identify the variable and define it. M is going to equal the number of miles. And so now I can come back to my algebraic expression. It's $1.75 and 65 cents for every mile. So 65 cents times every mile, or 65 hundredths times M. This right here is the cost of her taxi cab ride. Now we can finish this up as an inequality. That cost has to be no more than $10, no more than $10, which means that amount has to be less than, or it could even be equal to, $10. Could flip it around. $10 to be greater than or equal to $1.75 plus 65 cents, or 65 hundredths times M. There we go. How'd you do?